Section 2, Factoring Trinomials. This comes out of our Chapter 6, Factoring and Solving Equations. Here we will look to factor trinomials of the form x squared plus bx plus c. Let's think about what this is telling us here. A trinomial has three terms, an x squared term, a variable term bx, and a constant term c. So our three terms, our trinomial. What we saw in Chapter 5, multiplying polynomials, was that most often when we multiply two binomials, it often results in a trinomial. So our techniques here for factoring trinomials will help us in solving polynomial equations in 6.5. To factor a polynomial means we are going to rewrite our polynomial, which is the sum and difference of terms. We are going to rewrite it as the product of polynomials. Let's look at an example to start off here. For the first example here, it says fill in the missing factor. Then check your answer by multiplying the factors. Recall that if you are factoring something, you are just rewriting some expression as the product of two or more things. The number 12 can be rewritten as the factorization of 4 times 3, as 2 times 6, even 2 times 2 times 3. Here we have the trinomial x squared plus 8x plus 7. We want to be able to rewrite this trinomial using factorization. In other words, can we rewrite this trinomial as the product of its prime factors? Prime factorization for real numbers such as 12, we want to know what prime numbers multiply together to give us 12. Well, that is 2 times 2 times 3. Here, for trinomials, we want to know what prime polynomials. So even these polynomials here can be considered prime. That just means that they cannot further be factored. For x squared plus 8x plus 7, we are given one of the factors. X plus 7 is going to multiply some other factor, and that is going to result in an x squared plus 8x plus 7 trinomial. So the question here is, what do we need to multiply to the x plus 7 in order to get that trinomial? That will be our answer. That will be our missing factor. So we go to the board here, and again, binomial x plus 7 will multiply something in order to give us a trinomial. How could we multiply a binomial to something to get a trinomial? What should this be here? Again, more often than not, when you take a binomial and multiply it to some other binomial, it often results in a trinomial. For that reason, let's think through this. In Chapter 5, we learned that the product of two binomials, we use an algorithm called the FOIL method. Because when we multiply polynomials, we are simply using the distributive property. For each term in the first polynomial, we would distribute each term to each term in the second polynomial. But we don't know what our terms are over here. We need to determine that. This x here, if I were to multiply it to some term right here, the product of x and something else is going to give me x squared. What do I need to multiply to this x in order to get x squared? X times x is x squared. So we have something in mind here that this x times this x is x squared. Now this positive 7 multiply this x is a positive 7x. Okay, we need an 8x. How could we go from 7x to 8x? We need to add in an additional x. But how do we do that? Keep in mind, whatever we put here must multiply with this 7 in order to give us a 7, but it must also combine with this 7x to give us an 8x. So what could we do there? Positive 1. Let's see here that by running through the FOIL method, will the product of these two binomials actually give us this trinomial? Using the distributive property, if I multiply this x to this x, I get x squared. If I multiply this x to this 1 here, x times 1 or 1 times x is 1x, and we simply write that as positive x. But for now, I'll write 1x so we can see where it's coming from. The product of our inside terms here, 7 and x, is a positive 7x. And now, lastly, the product of our last terms, or our constants, the 7 and the 1, is a positive 7. So just as we saw in chapter 5, the product of two binomials, 2 times 2 is 4, therefore 2 terms times 2 terms, we get 4 terms. But from these 4 terms, we see that the middle 2 terms are like terms. Chapter 5, section 2 says when we have like terms that are adding or subtracting together, we can combine them by combining the coefficients. How many x's do we have? Well, here I have 1x. Here I have 7 x's. How many total? Total, I have 8 x's. So as we see here, x squared, this x squared is going to add the 8x, which will add 7. Confirming that the product of x plus 7 and x plus 1 is in fact x squared plus 8x plus 7. So what is our missing factor? We were able to find this missing factor by simply in our heads running through the steps for the FOIL method. The FOIL method is a distributive property. We distribute each term in our first polynomial. We distribute it to each term in the second polynomial by multiplication. In order to do so, we need to consider what will multiply the x plus 7 to give us our trinomial. Well, we want to think about another binomial that will multiply x plus 7, and that's x plus 1. Because we see here, once again, product of x and x is x squared. Product of 7 and 1 is 7. Our inner product 7x and our outer product 1x will combine to give us 8x. So our missing factor here is x plus 1. Looking at the next two examples here, I'll give you a moment to pause the screen and work out these two examples. It says for numbers 4 and 6, let's fill in the missing factor. And as always, we can check our factor by multiplying together our factors. It says here that the product of y plus 2 and some other factor, when we multiply these together, it will give us the trinomial y squared minus 2y minus 8. For number 6, the factor z minus 3, when multiplied to some other factor, will give us z squared minus 4z plus 3. Let's go ahead and go to the big board. Once again, thinking about our FOIL steps, what would we need to FOIL together with the y plus 2 in order to get the resulting trinomial? In other words, what should we multiply this y in order to get y squared? Y times something is y squared. Y squared indicates two factors of y. This is only one factor, so we need two factors. We introduce that second factor. Y multiply y is y squared. Now, what would we want to multiply to a positive 2 in order to get negative 8? What do we multiply to a positive 2 in order to get a negative 8? That's negative 4. Because positive times a negative is negative, 2 times 4 is 8, thus positive 2 times negative 4, negative 8. We also can confirm this by checking the inner and outer product. The inner product of positive 2 times y is positive 2y. The outer product, y times negative 4 or negative 4 times y, well, that's a minus 4y. And we see here that the inner and outer product produce like terms. Positive 2y minus 4y, well, 2 minus 4 is negative 2, thus we get negative 2y for our inner and outer product combining together. So first product here, y times y is the y squared. Our inner product and outer product combine to give us the middle term. And then the product of our last two numbers here give us the last term. That's the pattern we want to keep in mind. When we FOIL or distribute these two binomials, the product of the first two terms will give us the first term of our trinomial. The product of our last two terms will give us the last term in our trinomial. Now, this inner product here and this outer product, what do we mean by that? The inner terms multiplied together, the outer terms multiplied together will produce two different terms, for which we will combine together. 2y minus 4y, they're like terms, they simplify down to one single term, and that is the middle term minus 2y. So we've confirmed that the missing factor is y minus 4. For the next example, what could we multiply to z minus 3 in order to get z squared minus 4z plus 3? Again, think about distributing. We're going to distribute the z into our missing factor. We will distribute the minus 3 into our missing factor. We assume there that the missing factor is binomial because often the product of two binomials will simplify down to a trinomial. What do we multiply to the z in order to obtain z squared? Well, that is the variable z. Z times z is z squared. Now, what do we multiply to a negative 3 in order to get positive 3? Negative 3 multiply some number equals positive 3. That is minus 1. A negative 3 multiply negative 1 is positive 3. And once again, we see here the inner product, the inner two terms, minus 3 times z is a minus 3z. The outer product, the outer terms multiplied together, z times negative 1 or negative 1 times z is a negative 1z. So a negative 3z minus 1z, if you combine these two, a negative 3 combined with a negative 1, you get negative 4. So our middle term here, negative 4z, is the result of combining the inner product and the outer product from our binomial product. So when we FOILed this here, product of the first terms will give us the z squared from our trinomial. The product of the last terms will give us the last term of the trinomial. However, the product of the inside terms will combine with the product of the outside terms, simplifying down to give us our middle term here, minus 4z. So to factor trinomials of the form x squared plus bx plus c, what do we mean by this? Well, the b value and the c value, remember, they just represent real numbers. So as we saw, x squared plus 8x plus 7, where b equals 8 and c equals 7. Those are just placeholders. They are letters that represent numbers when we are trying to generalize something, just trying to base something off an idea. If I said to factor trinomials of the form x squared plus 8x plus 7, it makes it sound like that's the only example we get to use. So we want to be able to generalize that by just putting letters there and letting your mind wander. Plug in numbers for b and c. Those are the types of trinomials we will look at. Here in this section, our leading coefficient is understood to be 1. What is the number in front of x squared? There is no number. Therefore, the coefficient is understood to be 1. When your coefficient for the x squared is 1, it's understood. How do you multiply to get x squared? It's just x times x. What if, for example, that was 4x? Well, or excuse me, 4x squared. Well, to multiply to get 4x squared, I could do x times 4x. I could do 2x times 2x. So when that x squared has a coefficient other than 1, we want to be mindful that we will have a little bit different method of finding these results. But when we have the x squared term, it makes things just a little bit simpler for us. Now, as we've said so far, to factor a trinomial, we often see that the product of two binomials is a trinomial. Take, for example, the product of binomials x plus m and x plus n. Now, let your imaginations wander. Let m and n be any numbers you want it to be. This could be 1 and 7. Right, we just looked at an example where x plus 7 times x plus 1 is the result of x squared plus 1x plus 7x plus 7. Very similar to this. We're just generalizing it. We're not going to use real numbers 1 and 7. We're just going to use the idea of a number, which is a variable, m and n. So the product of these two binomials, as we know, will give us 4 terms. But those middle two terms, nx plus mx, these are like terms because they share the same variable x to the same exponent of 1. So combining the like terms, we add together the coefficients. We add the n to the m. So those two middle terms combine to give us the one term in the middle. The first term, of course, is our x squared. It is the product of our first terms x and x. And now that last term is a constant, because recall the m and the n are real numbers. M times n will be our real number. That will be our last term. That will be our constant c. Redefining n plus m to be b and redefining m times n to be c, we can get an idea. We get the sense here that the product of two binomials will often simplify down to a trinomial. This is how we worked it in chapter 5. We started with the two binomials, multiplied them together, and simplified to a trinomial. Here in chapter 6, we are trying to reverse that idea. We want to work backwards. If we are given the trinomial, we want to be able to determine what is multiplying together. In other words, what are the factors of this trinomial? Listed below here, we have a few examples of some trinomials in their factored forms. So again, understand that when you look at the trinomial form to the right, x squared plus 4x minus 5, how did we get there? We are going to start with the trinomial form. We want to work our way back to the factored form. What multiplied to give us that trinomial? As you see, we are going to reach a middle step because we need to determine what were those four terms that simplified down to three terms. Well, what do we mean about those four terms? Those four terms that were the result of our distributive property, of our FOIL method. So take a moment here to pause this screen, write out the binomials and multiply them together. Run through the FOIL process, run through that distributive FOIL process, and simplify the like terms, which happen to be your outer and inner products. Look at the FOIL, look at the O and I columns. Notice that the O and I columns all have like terms. It's because when you multiply these binomials, you often see that the result of the outer and inner products are like terms, simplifying down to that of a trinomial. So we'll look at an example here. We're being told to factor the trinomial x squared minus x minus 6. We need to think about how we got here. If we have this trinomial form, what are the factors that are multiplying together to give us this trinomial? In other words, we know how we received that first term. For x squared minus x minus 6, we see that we have a trinomial. If this can be factored, it may not be factorable. Think about the number 17. Can you factor 17? 17 is a prime number. We can only rewrite 17 as 1 multiply 17. We can't write it as 3 times 5 or 3 times 6 or anything like that. It's 1 times 17, with integers, of course. For a polynomial, if you can't factor it, then it's understood to be prime. In other words, you can only write it as itself times 1. You can't write it as a binomial times a binomial. As we've seen, all of these examples to the bottom right of the PowerPoint there, all of those trinomials in the trinomial form, those are composite polynomials or composite trinomials. In other words, they can be factored. If we could not factor that trinomial, then we would call it prime. Let's see if we can factor this trinomial x squared minus x minus 6. It's a trinomial. Often a trinomial is the product of two binomials. So we will start this by writing two sets of parentheses sitting next to one another. Recall that when parentheses are touching one another, it means that something's multiplying something else. So we're going to have something here multiply something here, and that would result in the trinomial x squared minus x minus 6. Let's think, what do we need to multiply to give us this trinomial? Well, think about what we just said before. What would multiply to give us the x squared? That's going to be the terms that will go first for each binomial. Whatever goes here and here, when we multiply them together, that should equal x squared. What times what equals x squared? Well, that is x times x. X times x means we have two factors of x. Factors mean multiply, so we're multiplying two x's. In other words, we can write it in the exponential form x squared. So now we know that the first term for this polynomial factor is x. The first term for this polynomial factor is x. Now, what will multiply to give us a negative 6 while at the same time combining together to give us this b coefficient? Well, what is this number here? What is the number in front of the x? If we don't see one, it's understood to be 1. So here our b value, as we see, x squared plus bx plus c. This tells us that our b value is negative 1. Our c value is negative 6. So in order to determine what goes here and here, we ask ourselves this question: what two integers will multiply to give us our c value, our constant of negative 6, while at the same time combining to give us negative 1? And I'll write that out here. Pause the screen if you need to. The question here becomes, can we find two integers that multiply to equal our c value, negative 6, that will also combine in terms of addition or subtraction, depending on what the sign is for them? Can we combine these two numbers in order to equal negative 1? Well, to do this, it's not too bad. The first thing we want to start off with is, can we find the two numbers that multiply to give us negative 6? Well, to find two numbers that multiply to give me negative 6, let's find the factors of negative 6. What two numbers multiply together to give me negative 6? Well, I'm going to start off with the easiest one, 1 times negative 6. 1 times negative 6 is negative 6. But will these two numbers combine to give me negative 1? No. 1 combined with negative 6 is negative 5. So for example, if this was a minus 5x in the middle, x squared minus 5x minus 6, then I would use the 1 and negative 6, because x plus 1 multiply x minus 6 would be x squared minus 5x minus 6. But we have the minus 1x in the middle. So these are not the correct factors that we want to use for negative 6. Well, if 1 and negative 6 doesn't work, what about negative 1 and positive 6? I'm just switching that negative sign here. We still see a negative 1 times positive 6 is negative 6, but will these combine together to give me negative 1? And that answer again is no. Negative 1 and 6 is positive 5. We would use these two integers here if this was x squared plus 5x minus 6, but it is not, so we don't. Are there any other factors of negative 6? Because if there aren't any factors of negative 6, or any other factors, then it would tell us that there is no way that we could factor this. This would be prime. However, we have some more factors. What about 3 and negative 2? 3 multiplied 2 is 6, therefore 3 times negative 2 is negative 6. So these multiply to give us negative 6. Do they combine to give us negative 1? A positive 3 combined with a negative 2, well, using arithmetic, 3 minus 2 is positive 1. So once again here, this is a negative 1. These are not the correct factors. If this was x squared plus x minus 6, we would use these two. However, it's not, so we don't. Let's switch the negative sign. Let's make this a positive 2 and make this a negative 3. Again, 3 times 2 is 6. Therefore, negative 3 times positive 2 is negative 6. When we combine negative 3 and 2, a negative 3 combined with a positive 2, negative 3 plus 2 is negative 1. Notice these are the two integers that will multiply together to give us negative 6, and they will also combine negative 3, positive 2. These combine to give us negative 1. They multiply to give us c. Because we found these two integers, it tells us that this trinomial is factorable what are the factors? For the first one, just choose either one of these numbers to plug in up here. I'm just going to go in order from left to right. The first binomial factor is x minus 3. Using this integer 2, our second binomial factor is x plus 2. The product of our binomials x minus 3 and x plus 2, these two factors here, when multiplied together, will give us the resulting trinomial. We can always check this by simply using the distributive property. Distribute this x to each term in our second polynomial. X multiplied x is x squared. X multiply a positive 2, or in other words, positive 2 multiply x is positive 2x. A negative 3, so now that we've exhausted all those possibilities, this x multiplied each term over here. Now we will let this negative 3 multiply each term over here. Negative 3 multiply x. Negative 3 multiply positive 2. And again, as we see, now we're understanding where this is coming from. Because if I factor a trinomial, I'm using the FOIL method and I'm reversing the steps. Because I'm working in reverse, I'm working backwards. If I have to use the FOIL method steps 1, 2, 3, 4, then to factor, I'm going to back up those steps 4, 3, 2, 1. I'm working those steps in reverse. Now we see it's being played out. Multiplying to use FOIL method, first, outer, inner, last. We get 4, because again, 2 times 2 is 4. 4 terms. X squared minus 6. What about the two terms in the middle? A positive 2x minus 3x is a minus 1x. That's why we want to know this. Two numbers that multiply to give us c, that will add to give us b. That's the question we want to ask ourselves to determine if this trinomial of the form x squared plus bx plus c is or is not factorable. Because right here, the product of these two numbers, the product of the negative 3 and 2, is going to give us this c value, negative 6. These two values here, when we do the inner product, this negative 3 becomes negative 3x. This positive 2 becomes positive 2x. Combining the like terms through addition or subtraction, negative 3 plus 2 gives us that middle term minus 1x. That's why we're asking this question here. Find two integers that will multiply to give us this value, but at the same time will also combine to give us this value. If you can find those two integers, then for a trinomial of this form, you will have its binomial factors. Another thing to keep in mind, had we written this in a different order, say for example, we wrote this as let's say we switch this around and we actually wrote x plus 2 first, and then we wrote x minus 3. Will this still give us the same value? Of course it will, right? Because when we multiply real numbers, it's commutative. The commutative property of multiplication exists. That tells us that 4 times 3 we know is 12. What if we switched those factors around? Switching the factors when we multiply 3 times 4 will still result in a 12. These binomial factors represent numbers such as 4 and 3. Therefore, we are allowed to switch around the factors when we multiply. Our factors x plus 2, x minus 3 are multiplying. Let's check this using the FOIL method. Product of the first terms here, x and x is x squared. Our outer product is the minus 3x. Inner product is the positive 2x. The last product is the minus 6. Once again, we see here that our inner and outer product will combine to give us that middle term, minus 1x. Verifying, confirming that these binomial products are commutative, and it doesn't matter the order in which we write them. But at the end of the day, once we have these factors, let's go ahead and use the FOIL method to confirm. This combining down to give us the minus x, therefore, x squared minus x minus 6. That confirms that we are correct. Therefore, what are the factors for this trinomial? The factors of x plus 2 and x minus 3. So to see here on video, we have our guidelines for factoring trinomials of the form x squared plus bx plus c, where again b and c are just any real numbers. Last example, b was negative 1, c was negative 6. So to factor the trinomial of this form, we will need to find two numbers whose product is C and whose sum is B. If C is a positive value, well, that tells us the product of two numbers is positive, indicating that the two values, m and n in this case, have to have the same sign. If C is positive, if our constant is a positive number, that means we had to either multiply together two positive numbers or two negative numbers. However, if C is negative, then m and n have unlike signs. In other words, one of the numbers will be positive, one of the numbers will be negative. In our previous example, our C value was negative. C equaled -6. And we saw that our m and n values were -3 and +2. One of the numbers was negative, one was positive. Those are unlike signs. Because C was negative, we should expect that. Negative number multiply positive number will give us a negative number. However, a positive times a positive number is positive. A negative times negative number is positive. So when C is positive, we have to consider, are the two constant terms m and n, are they both positive or are they both negative? Let's look at another example, x squared plus 5x plus 6. What's the first thing that we notice about this trinomial? All three terms are positive. We have a positive b, which equals 5. We have a positive 6, which is our C value. So in order to multiply to get a positive 6, either both numbers in our binomial are either positive or they're negative. Now, if they're both positive, two positive numbers will combine to give you a positive number. However, multiplying two negative numbers will give you a positive value, but when you combine two negative numbers, it'll give you a negative value. So again, the question here is what two integers will multiply to give us 6, but will also combine to give us positive 5. In order to multiply two integers and get a positive number, and at the same time combine two integers to get a positive number, both integers must be positive. So what are the positive factors of 6? We have 1 times 6 and 2 times 3. 1 times 6 is 6. However, 1 combined with 6 is 7, not 5. 2 times 3 is 6, and 2 combined with 3 is 5. So the two integers that multiply to give us C, that add to give us B, will be the integers 2 and 3. And both of those integers are positive. So to factor the trinomial x squared plus 5x plus 6 as the product of two binomials, we understand that each binomial will have the first term x, because the product of first terms x and x is x squared, and we fill out that binomial product with the two integers that we just found, 2 and 3. The product of x plus 2 and x plus 3 will give us x squared plus 3x plus 2x plus 6, where the combination of like terms, 3x and 2x, will simplify down to 5x for a simplified trinomial x squared plus 5x plus 6. Let's look at factoring the trinomial x squared minus 8x minus 48. X squared minus 8x minus 48 is the trinomial, and we are being told to factor it. In other words, what polynomials, what variables, what factors will multiply together to give us this trinomial? Oftentimes here, well, first question, remember section 1 says, anytime you're trying to factor, determine, is there a greatest common factor? Looking at all three of these terms, do all three of these terms share something in common? Is there anything we see there? I see that there are two factors of x here. There is one factor of x here. There are no factors of x here. So we can't factor out an x. Can we factor out maybe a real number that is a factor? Well, 48 is 6 times 8. It's 12 times 4. There's so many different factors for 48. 8 is 2 times 2 times 2. This is understood to be a 1. And recall that the greatest common factor for our coefficients, our real numbers, 1, 8, and 48, is just 1. So there's nothing we can factor out of here. There's some other method of factoring that we need to consider. And that is that trinomials are often the product of binomials. In other words, the product of two binomials oftentimes will simplify out to a trinomial. So how can we go from here to here? What did we need to do? Well, thinking of this as a binomial, there's two terms here, and there's two terms here. In the middle, there's either a plus or minus sign for each of our two binomials. For the terms to go here, when they multiply together, they give us the x squared. So what two terms multiply to give us x squared? X times x. All right, so we have an idea that x times x is x squared. X times some number is some number times x, right? And then our inner product will be some number times x. We will have our inner product and outer product be like terms for which we will then combine down to one single term, and that will be the minus 8x. So we need to be able to combine these two terms in some way that will give us a minus 8x, while at the same time, these two numbers must multiply to give me a minus 48. So what two numbers can I multiply to get a minus 48? What two numbers can we multiply to get a minus 48 that will at the same time combine to get us a negative 8? So two numbers that multiply to give us negative 48. Well, that has to be unlike signs. In other words, one of these numbers has to be positive and one of these numbers has to be negative. Well, let's think about all of these factors that will multiply to get us a negative 48. We have positive 1 multiply negative 48. That will get us negative 48, but will it combine to give us negative 8? No, this combines to get us negative 47. 1 combined with negative 48 is negative 47. That's not going to help. Negative 1 multiply 48 is negative 48, but when we combine, it's 47. That's not good either. So we just run through each of these possibilities until we figure it out. And if we can't, then it might be the fact that we cannot factor this trinomial. Other factors of 48. 48 is even, so it's divisible by 2. 2 times 24. Now this is negative 48, so we need a negative factor in here. Negative 2 times 24 is negative 48, but these two combine to give us positive 22. That's not negative 8. When I switch the sign, notice that it combines to give me a negative 22. So pretty much the opposite of what I just said. Positive 22, negative 22. Remember that the negative of something is simply the opposite of it. Negative 8 is the opposite of 8. Negative 22, positive 22. Neither combine to give me negative 8, so I'm going to skip over those factors there. And we keep going. 3 times 16. Well, negative 3 times 16 is a negative 48, but it combines to give me positive 13. If I switch the sign, the product is still negative 48, but now it combines to give me negative 13. I'm getting closer, but not exactly negative 8 yet. 48 here? Divisible by 4, right? Because we know 48 inches is 4 feet. There's 12 inches in a foot. Okay, so 48 divided by 12 is 4. Therefore, 4 times 12. 4 times 12 is 48. Now this is negative, so let's make one of these factors negative. Negative 4 multiply positive 12 is negative 48. But when we combine negative 4 and positive 12, we get positive 8. We need the opposite of that. How do we get the opposite? Let's switch the sign. A positive 4 multiply negative 12 is negative 48. And a positive 4 combined with a negative 12 is -8. So these are the two integers that we want to use. We are going to plug in a 4, which is positive. So up here, we will write +4. Our second integer is a -12. So in the second binomial, x minus 12. We think we have it. The two binomials, x plus 4 and x minus 12, when multiplied together, should result in the trinomial x squared minus 8x minus 48. Let's verify this result. All right, this is the check. This is what we want. We want the factors that multiply to give us the trinomial. We want to factor. So we have them. Let's just check and see if it makes sense. Distributing each term in the first binomial to each term in the second. X multiply x is x squared. X multiply -12 and -12x. Now we will distribute the 4 to each term in the second binomial. And notice I'm saying distribute, but I really mean the FOIL method, right? Distributing here and here, well, that's product of first terms, product of outside terms, product of inside terms, product of last terms. We are using the FOIL method, but we're also using the distributive method twice. We are distributing each term in the first polynomial to each term in the second polynomial. So for the second term, 4 multiply x, a +4 multiply -12. And we see that again, binomial times binomial, a 4-termed polynomial, but we have 2 like terms in the middle because they have x to the first power. How many x's do we have? I have -12, but I add 4, so combined to get -8. So we have verified that this product is in fact the trinomial we began with. So now it says that we have correctly factored our trinomial. The factor of this trinomial, or the factorization, is x plus 4 and x minus 12. This product here will give us our trinomial. At the top right, factor the trinomial 14 plus 5x minus x squared. Now we're looking at this and thinking that it is not in the same form that we have seen so far. But note that this is a trinomial because there are 3 terms, and it is a quadratic expression because the largest exponent in our trinomial is a 2. The largest exponent is a 2, so it's second degree, and a second degree polynomial is a quadratic polynomial. Let's go ahead and write it in the standard form by putting the largest exponent term first, followed by the next largest, etc. In doing so, the minus x squared gets pulled out front, the positive 5x stays in the middle, and the 14 out front, because it is positive, it goes to the end as a plus 14. Now we have it as the x squared plus bx plus c, but we notice we have this minus sign out front. And now when we're dealing with the minus in front of our x squared, keep in mind, we are factoring of the form x squared plus bx plus c. It says nothing about negative x squared. Now, we can stop here and think to ourselves, we've been multiplying binomials, and the product of the first terms gives us this right here. What would multiply to give us negative x squared? Well, x times x is x squared. With a minus, just throw a negative sign out in front of one. A negative x multiply x. A negative x multiply x, where we know that x times x is x squared. So this is simply negative x squared. So now we understand what multiplies to give us this. It's the negative x and the x. But I want to bring caution to that, because what did we just do? We just showed that multiplying negative x and x together, it's really 3 factors. A negative x times x. When we simplify by combining the x and x factors. X times x is x squared. But what does this negative out front indicate? Remember that a negative indicates a factor of -1. So negative x times x is really the negative of x times x, which is really -1 multiply x. So what we see here is that when you throw the negative out in front of the x squared, we really have that introducing the factor of -1. When you have a factor of -1 as your leading coefficient here, it is always best to, when simplifying, to factor out that negative, because what it does is it further exposes an additional factor in your trinomial. This trinomial here isn't just going to be the product of two binomials, it is going to be the product of two binomials multiply -1. So we'll have three factors. We will have two binomial factors, and we will have the -1 factor. Let's see how we do that. Because again, the name of the game here is to factor. Factor your polynomial. Even if that means to factor out a negative sign, because a negative means you have a factor of -1. You are exposing that extra factor that you didn't realize you had initially. The leading coefficient is negative. Anytime your leading coefficient is negative, that first term is a negative, whether it's -1 or -7, -2, consider factoring out the negative sign. Let's go ahead and see how we do that. So again, these equalities is going to hold because whatever we write here, it's going to express the same exact thing as what we have up here. Except we're going to move the negative out front. Anytime you factor, again, what are we factoring? A negative. That negative is understood to be a -1 if we want to see it that way. When we factor, introduce parentheses to determine what's left behind. Factoring out a negative, you are simply changing the sign for each of your terms. -x squared, well, that negative is getting pulled out front, making this +x squared. A +5x, well, a negative is getting pulled out of a positive. This is going to make this a -5x. +14, but a -1 factor gets pulled out, making this a -14. And now we can see through the distributive property, -1 multiply x squared, we're back to where we started. A -1 times a -5x is +5x. -1 times -14, +14. So right now we have rewritten this trinomial as the product of the factors -1 and x squared minus 5x minus 14. We're not done though, right? Because in order to be done, in order to say that we have completely factored our trinomial, we have to make sure that there are no other factors that can be further factored. -1 is its own prime factor. However, we now have this resulting trinomial, so we should ask ourselves, does this leftover trinomial here, which is its own factor, it's multiplying -1, but can it be further factored? Because we think about this, -1 can multiply 12, right? -12 is -1 times 12, but just because we rewrote this as this doesn't mean we're done factoring, because 12 we know is 3 times 4, and 4 is 2 times 2, so we could rewrite this as, we could always continue to try to further factor until we get to that point where all of our factors are prime. In other words, we can't further factor. Here, same concept. Can't do anything about this, but I can still look at this and determine, just like the 12, can I further factor? Ask yourself, can you find two integers that multiply to give you -14 that will also add to give you -5? So run through the integers that multiply to give you -14. Right, those are the two easiest to start with. To multiply to give you a negative, one must be positive, one must be negative. What else multiplies to give us 14? And those are all of the factors that will multiply to give us -14. Now, which of these will combine to give us -5? 1 combined with -14 is -13. -1 combined with 14 is +13. 2 combined with -7 is -5. And just to show you that this will be the only pairing that will work, -2 combined with 7 is +5. So those are the two integers we want to work with, 2 and -7. We will use these two integers as the m and n values for the x plus m times x plus n. So what do we have here? We still have that factor of -1 out front, and -1 is multiplying our trinomial, but we just saw that this trinomial is factorable. We found two integers that can break apart this middle term. +2, -7, results in x plus 2 and x minus 7. Why is that the case? It's because this minus 5x, we are rewriting using these two integers here. Think about reversing the FOIL steps. X times x is x squared. 2 times x is 2x. X times negative 7 is negative 7x. 2 times negative 7 is negative 14. We would start here in chapter 5, use FOIL to get these four terms, combine the inner and outer product, in other words, these two middle terms, because they are like, we would combine them to get that middle term negative 5x. We're just reversing those steps, reversing that idea. If we can find those two integers, 2 and negative 7, that multiply to give us c, that add to give us our b equals negative 5, then what we're doing is we're splitting apart that middle term using the combination of the two integers that we found, and those two integers, as we see, will multiply to give us our c value of negative 14. So what are the factors here? We have the factors negative 1, x plus 2, and x minus 7 that will multiply together to give us the trinomial negative x squared plus 5x plus 14. Again, just to get that on the slide there, we have our print. So now we're going to look at some examples, give you a moment there to pause the screen if you need to. And we will work out problems 13 and 19. We're being told to factor the trinomial. And note that some of the trinomials may be prime. In other words, we may not be able to factor them. For x squared plus 6x plus 8, two numbers that multiply to give us positive 8 that at the same time will add to give us the 6x. Two numbers that multiply to give us positive 8 that will add to give us a positive 6. So they must both be positive if we can factor it. Factors of 8, 1 times 8, well, that combines to give us 9. 2 times 4 is 8, and 2 plus 4 is 6. So a positive 2x plus a positive 4x. That was our result here. How did we get to this plus 6x? Well, we added together the 2x and the 4x, and we saw here that the product of 2 and 4 gave us 8. How did we get x squared? It was the product of x and x. So it's almost like, again, we're just breaking it down. How did we start with the FOIL method to get here? We see that because 2 and 4 multiplied to give us 8, and they also added to give us 6, the FOIL method had that our first term product was x and x, our outer and inner product was the 2x and the 4x respectively, and our last term product was 2 and 4. So what would this look like in the FOIL format? Well, x times x, this is the product of the first terms. This is the product of our outside terms, our inside terms, and our last. FOIL comes from the product of two binomials. So the product of first terms here, x times x. The product of our outside terms was an x into 2, which means we're going to write the positive 2. And then the inside product is positive 4. Again, as we see, x times x, which is x squared, x times 2, which is 2x, 4 times x, which is 4x, 4 times 2, which is 8. And of course, this binomial product is exactly the same. It's equivalent to saying x plus 2 times x plus 4. Doesn't matter which order you write it. X times x is still x squared. X times 4 is still 4x. X times 2 is still 2x. That still combines to give us 6x. 2 times 4 is still 8. So that is our factorization. Looking at number 19, x squared minus 9x plus 14. We want to know, can we factor this trinomial? In other words, can we find two integers that will multiply to give us positive 14 that will add or combine to give us negative 9? two numbers have to multiply to give us a positive, so either both of those numbers are positive or they're both negative, but at the same time they had to add to give us a negative. Well, two positive numbers cannot add to give you a negative. Two negative numbers will multiply to give you a positive, and they can combine to give you a negative, so these integers must be negative. Now what are they? Well, negative 1 times negative 14 is positive 14, but this combines to give me negative 15. Not negative 9. What are the other factors of 14 again? What about negative 2 times negative 7? Negative 2 multiply negative 7 is positive 14. Negative 2x minus 7x minus 2x minus 7x is minus 9x. Minus 2 times minus 7 is positive 14. So we found those integers that will multiply to give us c, that will add to give us b. Now, what multiplied to give us x squared? Well, that was, of course, x times x. So what is our correct factorization here? Well, thinking about factoring as the reverse of our FOIL steps, think about while we're saying the reverse of it. Normally, we start with two binomials and we multiply them out and then we combine them. Now we are reversing that. Instead of going 1, 2, 3, we are going 3, 2, 1. Product of the first terms is x and x. Well, they go here. The product of our outside terms, negative 2 and x, negative 2. Product of our inside terms, negative 7 and x. Product of our last terms, negative 2 and negative 7. Or in other words, negative 7 and negative 2. And you can always check that. X times x is here, x squared. A minus 2x minus 7x is minus 9x. Minus 7 times minus 2 is a positive 14. Number 31 at the bottom right, y squared plus 5y plus 11. We ask ourselves the question here, two numbers that multiply to give you 11, that add or combine to give you 5. Now 11 is positive, the 5 is positive, indicating that if we can find these two integers, they must both be positive. Well, what two numbers can multiply to give us 11? We have 1 times 11, and that's it. 11 is a prime number. There are only two integers that multiply to give us 11. We have a positive 1 and a positive 11. We also have negative 1 times negative 11. However, a negative 1 and a negative 11 will combine to give us a negative, and here we combine to get a positive. Well, what about 1 and 11? 1 times 11 is 11. 1 combined with 11 is 12. That is not 5. Because of this, because 11 is prime and it only has those factors 1 times 11, these are the only positive factors that will give us 11. And we see here that 1y plus 11y is 12y. That's not 5y. Therefore, this trinomial is not factorable. In other words, we have a prime polynomial. It cannot be factored. Just like the number 11, we can write it as 11 times 1. And just like this trinomial up here, we can rewrite this trinomial as the trinomial times 1, because what do we know about multiplying by 1? It doesn't change anything. And that's not really too interesting. If you can't rewrite this trinomial as the product of something else and something else, then it's considered prime. Just like the number 11. 11 cannot be rewritten as the product of two other numbers. 12 is 3 times 4 and 2 times 6 and 2 times 2 times 3. It is composite. It can be rewritten as the product of prime factors. Y squared plus 5y plus 11 cannot be rewritten as the product of prime factors. If you try it out, again, FOIL is y squared. The outer product is 11y. Inner product is 1y. That gives us the positive 12y. 1 times 11 is 11. So the only trinomial that will work with these two positive factors, 1 and 11, is this trinomial here. This trinomial can be factored into the product of y plus 1 and y plus 11. It is not prime. However, this trinomial cannot be factored into any binomial product, into any polynomial product. Therefore, it is a prime polynomial. Bottom right, number 24, x squared minus 8x minus 240. We are being told to factor the trinomial. Again, as always, just consider, is there a greatest common factor? The variable x is not present for all three terms, so we cannot factor out an x. The coefficient here is understood to be a 1. The coefficient of 1, 8, and 240 cannot have anything factor out of there because there's nothing common other than the 1. So what are our other ways of factoring here? Let's consider that a trinomial is normally the product of two binomials. We have seen thus far that in order to multiply two terms to get x squared, that is generally the product of x and x. So now we're to determine what are the terms that go here, and what are their signs? Is it a positive? Is it a negative? Are we adding or subtracting? We ask ourselves the question, what two integers will multiply to give us negative 240? Two integers that multiply to give us the negative 240. But at the same time will combine to give us negative 8. Again, we need to run through our factors of 240, more specifically a negative 240, but we'll do that at the end just by switching the signs around. We know that 1 multiplied 240 is 240, but we just need to take a negative and throw it in front of one of those factors to make it negative 240. Let's go ahead and list those. The factors of 240, we'll start with the easiest, 1 and 240. Of course, this product is positive, we need negative, so we'll just throw a negative in front. Negative 1 multiply 240, we're good there. But when they combine, it combines to get positive 239. That's nowhere near close to negative 8. Same thing for when we switch the sign to the minus 240. This combines to get us negative 239, nowhere near close. So let's be mindful that when we look for these factors of 240, when they combine to give us a negative 8, that either means that these numbers are small, like 2 and 6 combine to give us 8, but 2 and 6 nowhere near multiply to give us a large number like 240. We see that this sign is negative, indicating that the product of these two integers, one will be positive, one will be negative. When you combine a positive and negative number, that difference, or when their combination, might be small. We could work with really large numbers. 100 times 90, right, is 9,000. That's a really large number for a product. But if you combine 100 and 90, say for example, what if 100 was negative? Negative 100 times 90 is negative 9,000. A really small but large looking number at the same time because the 9,000 coefficient seems very large. But when you combine negative 190, it's really small. It's negative 10. It brings that middle number back down a bit. So for two numbers to multiply to get this large, we need to consider larger numbers in such a way that they will combine to give us negative 8. So let's think about some other numbers that multiply to give us 240. Well, 2 and 120, but that in no way combines to give us negative 8. 3 times 80, nowhere near close to combining to get negative 8. 4 times 60. What else do we have? 5 times 4, 8. 5 times 48. Sounds right. 6 times 40. 10 times 24. Let's start there. Ten times 24 is 240, but we need a negative factor. Negative 10 multiplied 24 is negative 240, but when we combine, we get positive 14, right? Negative 10 combined with positive 24 is a positive 14, not negative 8. So let's switch these signs here. Let's make the 24 negative. 10 multiplied negative 24 is negative 240, But when we combine these two numbers, a positive 10 minus the 24, it's negative 14. It's not negative 8, but it's much closer to negative 8, as opposed to that 239 business, the 2 times 120 giving us a combination of 118 and negative 118. That's way too far off. But as these factors get a little bit larger, as we see on each side, and as they get closer together. Now, of course, we went from a factor of 240 to a factor of 24. We're getting smaller, but you see on the other side that other factor started to get a little bit bigger. What are some other factors of 240? Let's go up a little bit bigger. Well, I know that the number 12 will go into 24 2 times, so the number 12, when multiplied not to 2, but 20. 12 multiplied 20. Think about that. 20 is 10 plus 10. 12 times 10 is 120. 12 times 10 is 120. 120 plus 120 is 240. So 12 times 20. And we can do that, right? Because multiplication is just addition over and over. So, and it was distributive property. 12 times 20 is 240. Therefore, negative 12 times positive 20 is negative 240. However, when you combine these two, you get positive 8. That's the opposite, so let's switch the sign. Positive 12 times negative 20 is negative 240. Positive 12 combined with negative 20 is negative 8. We found the two integers, a positive 12 and a negative 20. Our trinomial factors into the product of our x plus 12 binomial and our x minus 20 binomial. We, of course, can always check this, verify these results by distributing. X multiply x is x squared. X multiply negative 20 is a negative 20x. Positive 12 times x is a positive 12x. Positive 12 times negative 20, which we see to be negative 240. Our inner and outer product, negative 20x plus 12x, combine to give us our middle term minus 8x. Factoring, we're reversing the steps. We're flipping them from our FOIL. Start with binomials, multiply using FOIL to get to our trinomial. With our trinomial, determine what two terms did I had to combine to get negative 8x. Where at the same time those coefficients had to multiply to get negative 240. Well, that's again negative 20 and positive 12. At the bottom right of the screen, 3x plus 18 minus x squared, we are being told to factor the trinomial 3x plus 18 minus x squared. Now, we want to rewrite this in the standard form by writing largest exponent first, followed by the next largest, and so on. So we'll want to place the minus x squared out front, followed by the 3x, which is a positive 3x, followed by the positive 18. And we see we get the following trinomial in the standard form, noting here that our x squared is negative. In other words, our leading coefficient is a negative 1. So normally what do we want to do here? When we have a negative coefficient for the x squared, it introduces an additional factor, an additional negative factor. So let's expose that negative factor within our expression by factoring out the negative. So we're going to factor a negative out of each of the three terms. We do so by changing the sign of each term of our expression. The negative x squared becomes positive x squared. The positive 3x with a negative factored out becomes negative 3x. A positive 18 with a negative factored out becomes minus 18. So we have rewritten our trinomial in standard form, and we have now exposed two factors. We have a factor that is negative, in other words, a negative 1 factor, and we have this trinomial factor, x squared minus 3x minus 18. But just like a composite number, when you use prime factorization, you want to ask yourself, for the factors present, can we further factor? Can we further break down what we have left over in the parentheses? Well, in parentheses now you see we have this nice trinomial for which we'll ask ourselves the questions, can we find two numbers that will multiply to give us negative 18 that will add or combine to give us negative 3? Well, again, what is multiplying together? What is multiplying together to give us the x squared? That's x times x. Two numbers that will multiply to give us negative 18 that will also combine to give us negative 3. Well, here, to multiply to give us a negative, one must be positive, one must be negative. To combine to give us a negative 3, oh, well, the larger number, in a sense, must be the negative value. So multiples or factors of 18, 1 and 18, 2 and 9, 3 and 6. Which of those can combine in such a way to give us a negative 3? Negative 6 multiply 3 is negative 18. Negative 6, when combined with a positive 3, is negative 3. In other words, this negative 3x is the result of It's a result of the combination of negative 6x and positive 3x. Where do we get all of these terms? We are thinking about reversing our FOIL steps. In other words, product of our first terms, x times x, states that our two binomial factors here, the first term for each binomial factor, is an x, because we see x times x will give us the x squared. The minus 6x, that was our outer product. So a minus 6 and an x multiplied together. Here's the x. Here is our minus 6. Plus 3x implies positive 3. So as we see here, our negative factor, the negative factor, which is understood to be negative 1, multiply the binomial x plus 3, multiply the binomial x minus 6. These three factors make up our trinomial, which was at the beginning 18 plus 3x minus x squared, or 3x plus 18 minus x squared. All we did was rewrite number 22 in standard form, factor out the negative sign. So now what we have left over, this trinomial left over, after we factored out the negative, is easier to factor. Two numbers that multiply to give us negative 18 that will also combine to give us negative 3. Well, those two numbers are negative 6 and positive 3. So we plug them directly into our binomial product. Of course, I encourage you to use the FOIL method to check this. X times x is x squared. X times negative 6 is negative 6x. Positive 3 times x is a positive 3x. Those two terms combine to give us the one term here. Right here. They combine to give us the minus 3x. And lastly here, the positive 3 times negative 6 is minus 18. With the negative factored out, we now distribute the negative back through to give us negative x squared, positive 3x, and positive 18, confirming that we have the correct factors, a negative 1 factor, an x plus 3 factor, and an x minus 6 factor.